Okay, so this is an example of another way to do the roots. Now, once again, if you're raising trigonometric form of a complex number to a power, you have r cosine theta plus I sine theta, and you raise that to a power, you just get one answer. You get r to the n cosine times n theta plus I sine n theta. You just multiply this and raise r to the power. And then you can change it in a plus bi form if you need to. But this video is about taking a root of something. If you have r times cosine theta plus I sine theta, and you want to take the nth root of it, 1 over n, then you'll say r to the 1 over n power. But then you'll have to find all the angles that fit. So you'll take your angle plus 2 pi k divided by n plus I sine of theta plus 2 pi k divided by n. And k starts at 0 and then goes 1, 2, 3, however far you need it to go. If you're taking the square root, you'll need 2 of them. If you're taking the cube root, you'll need 3 of them, and so on. The reason you have 0 as your first one is it means like you're not going to add the period to it yet. You're just going to do it as is, and then you can add the period over and over again. And then when you divide by the appropriate number, it squishes it all back down to within 1 period. Alright, so I'm going to do x to the 4th plus 16 equals 0. And how does this fit into what we're talking about? In algebra, if I do negative 16, and then I take the 4th root of that, I have the 4th root of a negative number, which would usually throw me into imaginary numbers. And so I'm going to write it as a trig form of a complex number. So I'm dealing with x to the 4th equals negative 16, and then I'm going to take the 4th root of it. Alright, so the radius is 16 because we're trying to write this as a complex number, which is negative 16. And it's cosine, this is obviously back here at pi, plus I sine pi. So that's our number that we're going to take. This is negative 16 right here. If you distribute, you would get that. And now we're taking the 4th root of it. So this is all to the 1/4 power. So you start off with 16 to the 1/4 power. The 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. And then your first time around, you're going to have cosine of pi over 4 plus I sine of pi over 4. So what we just did was you took our angle plus 2 pi times 0 divided by 4. And so we just got pi over 4. By the way, since we're doing a 4th root, we're going to need 0, 1, 2, and 3. We're going to need 4 times around. 0, remember, means that you are not adding a period to it yet. You're just doing it as is. All right, then I'm going to have 2 cosine. All right, now I take pi over 4 and add 2 pi k, and now I'm using 1. So I just have 2 pi plus I times the sine of pi plus 2 pi, using this formula, pi plus 2 pi times 1 over 4. And then that gives me this. Two cosine of 3 pi over 4 plus I sine of 3 pi over 4. The fundamental theorem of algebra tells me I should get 4 roots. So the next one, I'm going to go cosine of pi plus, now I have k is 0, 1, 2, 3. I've gone like for my first time around, which is 0. And then I added a period to it, and I got this one. I'm going to add another to it. So that's 2 pi times 2, which gives me 4 pi over 4 plus I sine 2 pi k is 4 pi over 4, which gives me 2 cosine of 5 pi over 4 plus I sine of 5 pi over 4. And then 2 times the cosine. Now I add my final thing to it, where I'm saying pi plus 2 pi k divided by the number, which is 4. That'll give me 6 pi over 4 I sine of pi plus 6 pi over 4. Which gives me 2 cosine of 7 pi over 4 plus I sine of 7 pi over 4. Notice how these all fell. These are my 4 answers. 1, 2, 3, 4. Notice how they all fell before I got around to 0 to 2 pi. So it's a lot like when we were solving multiple angles. Now a quicker way to do this is to notice this. My first one gets me started. So I take the 4th root of it, so I have 2 cosine of pi over 4. Right, then I figure out what I'm going to add to it. So every time I go around, it's a 2 pi divided into 4 equal parts. So I'm actually adding pi over 2's, or 2 pi over 4's, every single time. So pi over 4 and 2 pi over 4 is 3 pi over 4. Add another 2 pi over 4, I get 5 pi over 4. Add another 2 pi over 4 and I get 7 pi over 4. And you can get your 4 numbers doing that. Now notice these are all going to be imaginary. Like if I figure out this one, so I'm done, unless I want to write it in a plus bi form. It says 2 times root 2 over 2 plus I root 2, over 2. Multiply by 2, you get root 2 plus I root 2. That's one of them in a plus bi form. You could write them all in a plus bi form. There are 4 numbers. They're all imaginary because x to the 4th plus 16 looks about like this, and there's no real roots. All 4 zeros are imaginary in the complex number system. Now if I check this one, let's just check this one. If I do that to the 4th power, I should get 16. Or I'm sorry, I should get negative 16 to solve this equation. So I have square root of 2 plus I root 2 times square root of 2 plus I root 2. Then I need 2 more, which I'll talk about in just a minute, to the 4th power. So x to the 4th plus 16 should equal 0. That gives me 2 plus 2i plus 2i plus 2i squared, which is negative 2. So when I multiply these two together, I get 4i. So that means if I had written 2 more of them down, that means if I'd written 2 more of them down, I would have had another, these 2 right here, would have also given me a 4i. And so this is 2 of them multiplied together, 2 of them multiplied together, so that I've actually raised this to the 4th power. I'm just checking it and proving that it works. So if I take this one times this one, I get 16i squared, which is negative 16, which if you fill it in right here, negative 16 plus 16 equals 0. So it shows that it solved the equation. So anyway, oh, another thing I wanted to show you is if I graph this one, it goes pi over 4 out 2. If I graph this one, it goes 3 pi over 4 out 2, 5 pi over 4 out 2, 7 pi over 4 out 2. So it makes this, all of these around the circle are evenly spaced every 90 degrees. If you do one that has 5 roots, a 5th root, they'll space around like evenly like 5 times when you plot